lot that we've learned, and we're coming before lunch, so I want to give a lot of time.
This is working? All right. First of all, I would like to thank Rob, Kerry, Maria, and everybody for putting this event together. And of course, I have to thank Helmut. Helmut, you never told me that we have so many chemicals here in New Jersey and in Philippines. I must say that my presentation is that I don't interact often with the community, and this is a great opportunity for me. I think that's something that we fail as scientists to do, and we really need to engage a little bit more with the community, learn from the community, and more importantly, communicating the research and health findings in a clear way. So, as you can see, I wear a lot of hats. I'm not going to go through this. You have it in, probably online. I'm directing the Nanoscience and Advanced Material Center. We do a lot of things there, but the core research of the center is we're trying to understand how particles, especially nanoparticles of all kinds, and emerging advanced materials and chemicals interact with biological systems. We're very interdisciplinary. We have material scientists, aerosol scientists, toxicologists, physicists trying to understand, as I mentioned, how nanoparticles interact with biological systems. But also, we have a huge translational research component. We're making materials as well. So we're trying also to address and make chemicals and materials and address emerging public health issues. So if I have time, I'll show you a little bit on that line of research, how we make sustainable food packaging materials that are biodegradable and non-toxic. That's the substitution of single-use plastics that we need to embed in strategies addressing plastic pollution. We have a lot of collaborators, both within Rutgers, but also at national level. I have to put some disclosures for funding sources. As you can see, our funding comes from almost every funding agency in the US, and we have also collaborations with industries. It's another disclosure. It's a company we founded last year. Actually, this company commercializes biopolymers as a food additive to control the digestion of absorption of fat and carbohydrates. So there are some good things there. If we bring into our research this sustainability hat, which means every time we make a new chemical material, we study its life cycles, implications, and make sure it doesn't happen. And that's something we fail miserably to do. In the US alone, every year we introduce 4,000 or 5,000 chemicals into the market. Only a very small portion of that, maybe 2-3% of those are primarily chemicals and materials that they are used in food or drugs that they go through basic toxicological assessment. The rest goes up there and will be coming the testing animals, and this is kind of a model that we're looking to change. So I will try to present in 15 minutes my journey into this plastic. I'll figure out how we ended up doing research on plastic pollution and microplastics. So we have a lot of projects, but I picked 6-7 projects that I will give you some highlights. And I'm going to focus at the end of what we really need to do, because that's at the end of the day, we created a mess. You heard from Matt and Rob this morning that we created a mess, and it's not just to identify if these microplastics that are out there, if they cause harm, but also how do we clean the mess? And that's, if you ask me, that's the bigger challenge. I'm going to start with the video. This is my little involvement with this advocacy group and the United Nations Environmental Pollutant. So this is a kind of a short video we put together that pretty much shows the first advertisements related to plastic.
Was fantastic.
By a miracle of modern science, a brand new world.
You won't believe it.
The possibilities of plastics are endless. The radio and the telephone depend on plastics. Handbags, shopping bags, shiny plastic shoes, nylon plastic too. Say, this isn't like the stuff my wife uses. It's clear. Wherever you look, there is another use of plastic.
But something was wrong with this fairy tale.
Modern plastics remain in their original state almost indefinitely. Ever.
There was no happily ever after.
By now, you did
There was only ever after.
Grandchildren will not see the end of it.
The problem is, we're now addicted to plastics.
Mass production, plastic on an industrial scale.
We've now produced enough of the stuff to wrap the world thousands of times over.
They look good.
So it's time to write a new story.
Try something new.
We must eliminate unnecessary plastics and redesign products to reuse, repair, and repurpose. We must break the habit today if we want a future free of plastic pollution. Now wouldn't that be fantastic?
It's very telling. There is, I will encourage all of you that to get involved. There are a lot of projects, especially outreach projects. It's a great program. So again, it's nice to come last because already Rob and Phoebe and Matt presented a lot of things, but plastic is fantastic. We use it in so many good ways, and it has amazing properties. It's not very costly, but it's in creative dimension, as I mentioned. So recent polls in the United States and Europe puts the concerns of the public on plastic pollution very high up. In Europe, I think it's even in the top 3 of the problems of our century. In the US, I think it still makes the 10 things on the list of the 10 more urgent pollutants of our time. So, and of course, you've seen this from Matt and Rob this morning. I won't spend a lot of time on this, but I want to focus on this. So, the plastics from the municipal solid waste in the US, the percentage of plastics in municipal solid waste is about 12%. I don't know the numbers from New Jersey. It might be worth to look closer into that. Bottom line, we didn't do a good job recycling plastics, 9%. We incinerate about 10%, the rest goes into landfills. So, we created this mess. We have 6 billion metric tons of plastics already out there. So if we stop today producing plastics, we still have 6 billion metric tons of plastics out there, and we really need to deal with that mess. This is also from EPA. They don't have data beyond 2018, but pretty much in the US, recycling is even worse. It's around 7%. We combust, generate energy about 16%. Rob and I, we had a master's student last year to try to sample some particles in Newark, in one of these municipal incineration facilities. We did find some plastics, so we have to repeat the study and quantify them. And of course, the rest goes into the landfill. It would be nice if we can have data, and that's something that we need help from the community for New Jersey. It looks like we're making plastics here. I didn't even know that we're making plastics in New Jersey, but it looks like we're making some plastics in the state. We already talked about this. Plastic is not one material. We have many polymers. You can see the quantities that we make every year. I want to emphasize the additives. Plastics are not virgin materials. We add additives there to give functionality. And those additives are really highly toxic. You can see a list of additives that usually are pyroplastics. And we have a lot of literature actually on these chemical additives that they are in plastics. And some plastics, they contain these additives up to 30-40% by weight. So this is a slide I borrowed from Philip Rantrigan. You can see the effects of these chemicals that they are in the plastics across the lifespan. So, and this is, we have historical epi and tox data on these chemicals. Of course, microplastics is not the leachate of chemicals from plastics. It's something different. You have a particulate form of material, and we'll be studying how particles behave in biological systems for a long time. So we know a lot about particles and how they interact with biological systems when they inhale or when they ingest it or when we put them on the skin. So we created these prices because these plastics, these petroleum-based plastics, are not biodegradable. Put them out there, they will stay, keep breaking apart, and they will pretty much pollute the air we breathe, the food we eat, the water we drink. We know also a lot about occupational exposures. Actually, I had a project funded by NIOSH about 10 years ago, looking for nanoplastics emitted from printers and photocopiers. I won't go into many details. We published a lot of papers confirming all kinds of health outcomes related to the inhalation of these nanoplastics from printing equipment. So there are occupational exposures, especially for people working in making plastics, recycling plastics, or even industries like the printing industry. So the area that we don't have solid data, and for people like myself that were involved with risk assessment, to assess risks, you need exposure data at the human population level. And of course, we need to bring toxicology into the picture to assess and characterize the hazard from whatever chemical. So we have very little data for human exposures related to plastics. And without having that, it will be really difficult to assess the risks. And that's the case always for emerging chemicals. Usually exposure assessment comes at the end, and there are other issues here. We don't have funding usually to do exposure assessment studies. In this particular case, and I think Matt made a very good case, we need also to develop analytical techniques to be able to quantify these emerging pollutant in environmental media, but also in biological systems, and that's not trivial. So it's not just to say we found microplastics in this organ and that organ. That's very important, and I think emerging biomonitoring studies pretty much confirm the presence of microplastics pretty much in every human organ. But we really need to assess the human population exposure. So there are a lot of studies emerging out there. I'm not going to go through the details. It's a very busy slide, but I think we know about the food we eat, the water we drink, lots of evidence. Also, I mentioned the human biomonitoring studies, and I think Matt also presented some really very alarming data, especially the presence of microplastics in the brain. There are all these very simplistic papers that they try to quantify, for instance, ingestion, and this is very alarming. We ingest 5 grams of microplastics in a week. That's the equivalent of a credit card. So the other tool that we use in risk assessment is studies, epidemiological studies. But of course, to do epidemiological studies, you need the exposure component. So there is not much on epi studies. It's only one just came earlier this year. I think I have a slide on this. But I like what my student put together here. This is watching your stomach. which is equivalent to what is in your wallet. Anyway, that's a paper one of our students tried to put together as a review paper earlier this year, just to show you that there is also, along with the exponential exposure production of microplastics, there is an exponential exposure of papers that the American Editor Chief of Nano Impacted were. And this year, we are bombarded probably by 1,500 papers every week on some sort of microplastics research. So I mentioned the EBI studies, but and also NIH finally came up with this notion to put as a priority research on microplastics and the health implications. So hopefully the funding agencies in the US, they will move a little bit more proactively. The Europeans are ahead, show a little bit of data because we're part of one of these European research projects. But in Europe, it's the precautionary principle for any chemical. In the US, we have to wait until people start dropping dead and then we do something. That's the difference between the US and Europe. So this is the only serious EPI study published a few months ago, which it's a more prospective study. It's about 300 patients. This is a study in Italy that they went carotid endarterectomy and they looked for the atheromas, and to make the long story short, they found that the group that they had microplastics in the atheromas, they had, and followed them for 3 years, they had 4.5 times higher risk to die from a MI, stroke, and the like. So we need more studies like this, and hopefully now that we're developing the analytical tools, especially pyrolysis, GCMS, we have one also developing one of our projects. It's going to help us to put more of the epidemiological studies that we need to point to specific diseases. So usually people ask me, where are we in terms of risks from plastics? And I think that's where we are. If you ask the scientific community, and I participate in panel reviewing grants, even scientists, even toxicologists, some of them they are not sure, and pretty much what we hear is we're not dropping dead from plastics. We've been exposed to plastics for many years, so we have a lot of work to do. And the good news is we've been studying particulate matter and particles in general, and the effect on human health in air pollution studies. Also, the nanotoxicology field has been around for 20-30 years, so we have a tool set, and hopefully we have the funding. We can utilize that tool set and we can start understanding a little bit mechanistically, and if we link that to the exposures, we can really assess the risk. So we'll be studying in my nanocenter nanoparticles for probably 20 years, all kinds of nanoparticles, environmental nanoparticles, engineered nanoparticles. We make some of these also in-house, so we have a lot of experience. We also, at least in my case, we focus on biopolymers for the last 6-7 years. So those are the cellulose-based particles or chiral nanoparticles. So those biopolymers, they have the potential to be used as substitutions in some of the food packaging and other applications because they are biodegradable, and usually what nature puts out there is not very toxic, especially in the form of plants and other sources. So we'll be studying, and I think I already mentioned that we have some very good projects and applications of biopolymers related to plastics as substitution, food packaging materials in particular, or nanocarriers for drug delivery, or nanocarriers for chemical delivery. All right, so in terms of research in our center, we have a number of grants. This is a grant we had this is the second year from USDA. And this is a very interesting topic. Maybe for New Jersey is also interesting because there are farmers. I don't know if there are farmers in this group, but this grant focuses on the crop exposure to microplastics and the potential on human nutrition and health. So it's a collaboration between Connecticut Agricultural Experiment Station and also NGIT. This is kind of a study design, but again, I don't have time to go into details, but we're studying how microplastics are interacting with other environmental pollutants in their journey in the environment, and what happens for the plants, especially edible plants. Are the presence of plastics, first of all, are the plastics are taken up by the plants? Is the presence of plastics affect other pollutants, the bioavailability of other pollutants? So we're making also some environmentally relevant plastics in our lab. And also when we consume these edible plants, what does it mean in terms of toxicological outcome? This is a new grant just funded by NIH. It's another one. It started in August. So this focuses more on the intestinality and biodistribution and toxicity of environmentally microplastics, and also if microplastics cause inflammation, and also we focus on vulnerable people with inflammatory bowel diseases. There's a lot of millions of people in the US, they have inflammatory bowel diseases. So we want to study using different biological systems what microplastics to this vulnerable population. So this just started, so I don't have anything to show. And also we have a third project, which is part of this European consortium on plastics, which was launched 2 or 3 years ago. We're part of Plastics Fade, and also we're trying to understand the health impacts of micro and nanoplastics. A few highlights. I know it took me a little bit longer than I expected, but so I think both Matt and Rob talk about the life cycle of plastics. So if you visit our labs, and I encourage you all to visit the Oshi, it's not far from here, when you have time, we can show you. We have developed over the years what we call life cycle platforms, that we can take any material, in this particular case, of course, plastics, and we can take it, we can put different stressors. It can be mechanical stressors, it can be UV weathering, photooxidation stressors. We can even, we have an incineration platform. We can even incinerate the plastic, and we can collect the outcomes from all these scenarios, and this is what we call environmentally relevant microplastics that we can use also we can make them in a reproducible way. We can use them also in our toxicological studies. One of the very first papers we published probably 5 years ago, which was very alarming. We focus on ingestion because, as I showed you earlier, 5 grams of plastics is in our stomach every week. This is a paper, this is a study that we launched, as I said, 4 or 5 years ago. And we wanted to see what happens in the small intestinal epithelium, how the cells are interacting, and if these particles of what kind of size and chemistry, if they're taken up, how they're taken up, and where do they go in the cell. So, I mean, of course, we discovered something that wasn't a surprise. We know that the smaller the particles, their ability to bypass biological barriers increases. So, what was very alarming is that we found that these particles not only are taken up in the cells, but also they can enter and interact with cell nuclei, which is very alarming. I think I have a video here to show you the video. It works. It's a confocal microscope video. You can see the blue is the nucleus of the cells, The red, they are these 25 nanometer plastics, and you can see them that they're making their way into the cell, into the nucleus. There's a paper it's a follow-up paper we just published a few months ago. We looked into mechanistic, how these particles, they enter the cells. And as I mentioned, we know a lot about particles and how they interact in the gut, but not all particles are created equal. I think the scary part of nanoplastics in particular is their hydrophobic nature. And I'm not gonna go through the details here, but we found that they're taken up both actively and passively, and I will explain a little bit what I mean actively and passively. Because of this hydrophobic nature, they can slice like butter through membranes and enter the cells. And you don't find them in endosomes, and that's the key. I mean, there are 5-6 mechanisms how cells can take up particles. We look at them, and that's the scary part, that they can enter, because of their hydrophobic nature, they can slice through membranes. It can be parasitic. I know. What is lunch? So anyway, now this is also very alarming. It's a study. As I mentioned, we've been studying how polymers, especially biopolymers, interact with the digestion absorption of micronutrients. And we developed cellulose fibers that we can control, that we can reduce the digestion absorption of fat, for example. And that's the company I mentioned earlier. But we wanted to know if micronanoplastics behave the same way, because they have completely, as I mentioned, different hydrophobic properties, or maybe they can increase the digestion and absorption of fat, for instance. So we look into fat. Those are incinerated micronanoplastics. Those are micronanoplastics that emitted from these municipal incineration facilities, or if you expose occupationally. I'm not going to go through and say how we do it. The bottom line is these incinerated micronanoplastics. We found that they can increase the absorption. I mean, the digestion of fat, the triglycerides, by 33%. But more importantly, they can increase the absorption of fat. So in other words, if you have micronanoplastics in your salad or in your food, the presence of micronanoplastics, they will increase the availability of fat by 2.4 times. So of course there are other studies. I'm not going to go through the mechanisms, but there are other studies follow this study, and for instance, there is a study published a couple of years back that they show that micronanoplastics, they can decrease the electrolysis in the liver and points to obesogenic behavior. So,
Doctor.
yeah. All right. Anyway.
There's so much great information.
All right.
This could be a continuation of part 2, and thank you all. Thank you so much. For your information. We are before lunch, so it is